All right. Well, we'll just start with some high level things here. Thank you everybody for joining us here today. Joining us after the Labor Day weekend and taking some time to learn about Continuum Powders, to learn about Knust-Godwin, to learn about Renishaw, all of our partners here, all of our collaborators on this program. We're really excited that everyone's taking some time out of their day to connect with us and to learn a little bit about this story. We've given this story the title of Enabling a Circular Powder Economy. I think a lot of people on the call are probably really eager to understand what we mean when we say a circular powder economy. That's a really general term. For Continuum, I think at the highest level, what we're referring to is providing sustainable powder to the market. And in this particular case, we've got an awesome case study, a really exciting case study with one of your biggest customers, Mike, who was able to take some end-of-life components and turn those components into gas atomized powder, and then use that powder to create new components that went back into downhole oil field applications. It's just a really compelling story that we wanted to share with the broader market. Some amazing partners that we worked with on this were Knust in Texas, Renishaw, and John. So Mike, thanks for joining us today. We've got John on the call here as well, who's going to provide some more color into how Renishaw supported this effort. But I think with that, we'll kind of just jump into the process here. So Mike, thanks again for joining us. We'll go ahead and kick this off.
Thank you, Michael, for having me, and I look forward to the discussion and telling our story about the Continuum powder.
Awesome. Let me pull up the slides here. Just to give you a feel for the flow, we'll spend a little bit of time talking to Mike and how he's worked with Continuum and Renishaw, and how he's been able to take these Continuum's metal powder and use it in his production process today. And then we'll spend a little bit of time getting to know the technology, the additive manufacturing technology that's being used here, which is the Renishaw machine, and we'll get to know John and his organization and what they've got going on in North America here, and we'll dive into their operation a little bit more. So with that, I'm gonna kick things off with Mike, and Mike, thanks for joining us today.
Thank you, Michael, for having me.
Yeah, of course. We've got a little bit of an introduction to the Knust organization, which is based just outside of Houston, Texas. But maybe just give us a little bit of an overview. What makes your shop so special? What kind of capabilities do you guys have?
Sure. Thank you. Knust-Godwin's been in the business for over 60 years, and we specialize in precision contract manufacturing. So we specialize in working with the exotic materials such as Inconels, titaniums, beryllium coppers, and so forth. And we're highly known for doing the unknown projects in the world, taking raw material and producing very complex geometry products out of them.
Very cool. So over 60 years of manufacturing experience, you've got a lot of very established processes in place. When you first started hearing about additive manufacturing, I mean, what were you thinking? Are you thinking this is not for us? This is too high risk? Or what were some of the things that made you feel that this was something that you guys needed to begin to at least dip your toe in?
Yeah, we looked at it. I was pursuing an alternative manufacturing process to try to reduce lead times to our customers and eventually try to reduce cost. And additive manufacturing was something that was, popping up a little here and there, mainly in the polymers and plastics and things.
Sure.
And but I wanted metal. We produce metal parts, and I wanted to pursue metal additive. And at the beginning, it was very sluggish, slow to start, not a lot of people interested in it. It was very challenging to get our customers to actually one to pursue it. I mean, in the very beginning, there were times when I printed something and gave it away, just said, hey, try it, replace the existing part with this and try it and test it. We validated that it would meet the mechanical properties that it was looking to replace. So it was challenging.
Sure. Yeah. Most new things are, I think, as a lot of us here and on the call can probably attest to, and have been in AM for a while, have probably all shared some part of that story that you just described there. So I'm sure that really resonates with a lot of people on the call today. Just to hit on that a little bit more, I mean, I think you have a great success story there. Obviously, your additive manufacturing footprint has continued to grow over the years. Was there anything we're familiar with a lot of the parts of AM that are well talked about, increased design complexity, potentially lower lead times, but as someone who's really lived this for the last 14 or so years, as you grew your additive manufacturing capabilities, was there anything that surprised you along the way, or any misconceptions in the industry that you've come across?
Yeah, there was a lot of skepticism around metal printed parts. Are they as good as raw material products? Will they hold up? All those kinds of things were always leery in the beginning. I've heard people say, will they melt away when you use them and so forth. So we had a lot of, we held a really tight standards for it. And basically we were trying to mimic and duplicate raw materials. So if raw material was good in this alloy, then we felt like we could achieve it with printing the same alloy with all the post-processing and heat treating. We felt like we can deliver the same quality product. And yet still you had to prove to the customer. And once they started to understand that and then design for additive and take the benefits of additive into their design, and really they started seeing the benefits of, what it could do, how it could reduce cost, combining products together to reduce on part count and make assemblies a lot easier. So there was a lot around that and the qualification of the materials in the beginning.
Yeah, I think you hit a couple really cool points there where, as people that have been in additive for 5 or 10 years, we love to talk about it. We're all super passionate about it, but you can't do additive just because it's cool, right? I mean, as cool as it is, and as much fun as lasers moving around a build plate is, and seeing the sparks fly, as you mentioned, it's gotta make sense. It's gotta meet the material requirements of raw material or better, and it's gotta economically make sense. So I think you hit on some really good points there that Knust has been able to hit on, and be successful in that way. So why don't you tell me a little bit, a lot of your customers are being in Houston, are in the oil and gas industry. Have you heard your customers talk about sustainability at all in terms of manufacturing processes, in terms of decreasing their overall carbon footprints? Have you been involved in any of those kind of conversations?
Yes, it's really picked up over the last 3 or 4 years for sure. It's a requirement, right? Everybody's being driven to reduce their carbon footprint globally. All of our customers in the oil and gas industry are pushing that down, and everybody's looking at ways of cutting their carbon footprint. Additive is one of those ways. We're recycling, reusing powder. You're using less powder. You're not producing scrap from taking raw material and cutting it all away and leaving the finished product and throwing all the shavings away, or recycling the shavings. So with additive, you're basically reusing 85+% of the powder that produces the part. And so it's in everybody's mind, and everybody's focused on it, and it's something that's going to continue.
Yeah, 100%. I think we talk about buy to fly ratio a lot, or which is an aviation term, but I think the phrase kind of is well understood, that as much material or powder that gets converted into a usable part, we're massively increasing or decreasing our carbon footprint of this additive manufacturing process, which already is one of the more sustainable processes. So that's a great point that you make there. So along those lines, the last couple of years you've been feeling a little bit of that pressure to adopt more sustainable operations. Um, I think to tee up where Continuum comes in here is that one of your larger customers in the oil and gas space came to you with kind of with a problem or with more a technology for helping them solve one of their problems. So I've got an image here that kind of outlines a little bit of where our Knust and Continuum partnership began to kick off. But effectively, one of your large customers came to you with the idea that a company could recycle end of life oil and downhole oil and gas components and turn that into gas atomized powder. I mean, what was going through your mind when this first idea is pitched to you?
Yeah, it was one of our largest customers, and they actually, approached us about taking some end-of-life products and cutting them up and then sending them off to this place. And I was asking a bunch of questions about it, and at the time it was called Molly Works, and we were going to send the products cut up to Molly Works, and they're going to reprocess it. And since then, it's now it's Continuum, and I was a little skeptical because here we were for the last, 10, 12 years, really pushing additive and trying to say it's the same as the raw material. And,
Right.
we talk about, part of the qualifications always with everybody is, are you using virgin powder and so
Right.
on and so forth. And so I was a little skeptical about it because I was concerned that we're going to start going down this path, and then we're going to start isolating who's going to want to use it and not use it. And so we did it. We cut up the products and we sent them off. And a month or two later, I don't know the exact timeline, but all of a sudden some powder showed up and in the containers. And our customer approached us and says, we want to build a test matrix and let's qualify the powder. So still being skeptical, I was like, let me check the flowability of this powder. Let me check the,
Yeah.
the,
Yep.
the, the spherical shapes of the powder and make sure
Yep.
that in the sizing of the powder, make sure
For
everything's
sure.
going to flow. And we were still skeptical, and we put it in one of our Renishaw single laser machines that's easy to clean out and easy to process, prototype parts and, prototype, single batch materials and things like
Yep.
that. And we ran a little simple build on our own, and it worked great. We didn't do any mechanical testing at that time. We just said, hey, is it flow? Does it center?
Spread
And, does
goes
it,
across the build plate.
yep,
Yep.
yeah. And so we took that and then we said, okay, now let's take it and let's put some of this powder in our fully autonomous running Renem 500Q Renishaw system with 4 lasers. And we put the test matrix in there that we were going to produce, and we produced all the samples and everything that we were going to use for all the qualification testing. We printed it and it all came out fine and sent it off. We sent it to our customer at first, and our customer took that and sent it off for having all the additional processing done, the heat treating and the testing and everything. And a little time went by, and they came back to us and said, "Hey, anything you want to produce for us out of that material, go right ahead. We're good to go with it." And I started thinking about it, and it's like, wow, that must have really good results, that they are willing to take this step and move forward with it. And so it
Yeah.
got us thinking and got me to thinking about what can we do more here for having the full sustainability of recycling and recycling of products,
Sure.
oversized powder and so forth. And so
Yep.
we pursued this and ourselves and started
Yeah.
pursuing using the Continuum powder.
Yeah. Um, No, I mean, I think that's a great summary of how this program went from our eyes, and some of the questions that you were asking early on, and we get these every day. Is the first question people ask is this even possible? How are you going in a single step be able to take these awkward parts, alloy materials, and turn them into high quality gas atomized powder? And I think that was when we were able to demonstrate that. That's kind of a matter of just seeing it show up in the containers and, like you said, putting it in the machine, testing it, and seeing that it builds. And But secondly, the thing we get is, well, what are the trade-offs? Surely there's going to be some trade-off in this process. And I think as you outlined, and as we've got a nice slide here, that there are no trade-offs. The trade-off is that you're not using any materials that have been mined out of the ground, and they haven't had to be turned into an ingot and drawn and then melted. What we're able to provide to our customers is powder and material that performs as good or better than the incumbent. And I think that's what you saw, that's what your customer saw. And at the end of the day, it's a win-win. And for us, that's what we talked about at the beginning of, it can't just be a nice story. It can't just be a cool story. It has to actually make sense. And from at least from a quality standpoint, I think what we've got here and the tests that you conducted indicate that that from a quality standpoint there is no loss, and perhaps there's even some gains to be had there.
And it's not just a 1 or 2 time off situation. It's consistent. We
Right.
have the machine loaded in this powder, and we use it on a very consistent every day. We're printing with this powder, and we see these kind of results time and time again. And we're extremely excited about it, and it's shown that we can achieve and have better mechanical properties across the board.
Yeah, yeah, I love that, and I think that kind of brings us here to the end result. And while these aren't the exact parts that were used as a part of this program, but just representative of the fact that this wasn't just done to prove that it can be done. This was done to help you and your customers economically and sustainably make better parts, put some cash back into your pockets, put some cash back into your customer's pocket through material rebates, and to be able to continually use this to help bottom line and to help be more carbon efficient. So just seeing parts that you're printing and running every day that end up back into the oil field application, I think is kind of really brings the story together.
It does. It really does.
Yeah. I think we've got one last slide here, which just provides kind of an outline of the partnership that is Continuum and Knust and Renishaw, where just to put this all in a single slide and show how we're able to take end of life, nickel superalloy oil field components, and with a single processing step of cutting and sizing and putting into our metal to powder Greyhound system, using Renishaw's technology, using Knust years of experience in additive manufacturing to quickly qualify a new powder and bring a new part to a customer here, and be able to execute on this on a timely manner is just a great success story. And I appreciate you kind of telling this story on our behalf, Mike. I think you did a great job. Is there anything else you want to kind of close with here as we talk about this success story?
No, I mean, I think we all have to look at alternative ways of looking at what we can do to, reduce our carbon footprint. It's a concern for globally for everybody. And, we're going to be judged on this in the future. So I think it's a great step forward in looking at what we can do to help the environment for sure.
Awesome. Awesome. Yeah, I really appreciate it. Thanks, Mike. We're going to kick things over to John here, who is with Renishaw. And John, we want to give you a chance just to, tell us a little bit about the current state of Renishaw and what are kind of some areas of focus for Renishaw as a technology provider in the additive manufacturing space.
Yeah, sure. Thanks, Michael. Appreciate that. Yeah, so Renishaw it's about a 50-year-old company now. We just celebrated our 50th anniversary last year, founded in 1973. Our core competency is design and manufacture precision metrology equipment. So functionally, that encompasses technologies across machine tool spaces, gauging technologies like CMM, in our Equator line of products. We also have an additive manufacturing product line, which we're going to be focusing on here. And we also have some healthcare divisions as well. And overall, a lot of that metrology equipment is spread out across the entire manufacturing discipline, which includes companies like Knust-Godwin and Mike Corliss, who gave us a good little description there prior into the conversation. So our first real interaction with Mike was on the machining side. Technically, it wasn't necessarily always originating from the additive manufacturing side. We'll get into that in a bit more detail. But what we would claim within the market space itself is that due to the fact that our core metrology equipment leverages a lot of laser-based optical measurement technologies, that puts us in a pretty unique position relative to the additive manufacturing space from the OEM's perspective, in the sense that we leverage our own technology to manufacture our own machine platforms in-house. So the platforms themselves are quite vertically integrated, which not only gives us better quality control of the process in and of itself, because we're making our own machines, but also leverages and affords our end user customers more functionality in that regard, because it completely encloses the entire manufacturing loop. So obviously that's reciprocal benefit, not only for us, because we can leverage our own AM technologies inside of our own manufacturing disciplines, but also in our customers' hands as well.
Very cool. Yeah. I think one thing I didn't really appreciate is the global footprint that Renishaw has as an organization. Renishaw is a massive company that spans across the world. What does that mean when you're building an AM machine? How are you able to leverage being a part of that manufacturing supply chain globally across almost every manufacturing industry that you just mentioned there? I'm sure all of those pieces contribute to being able to make a precision and specialized machine, and aligns with a lot of the core competencies that you just outlined.
Yeah, for sure. We are a global company, about 36 subsidiaries all across the globe. I'm specifically based out of the North American headquarters, if you will, at Renishaw Inc., which is just outside of Chicago, Illinois. Across the entire portfolio suite, all the product that we sell throughout the world is designed and manufactured within the UK. Now, to your point about how we're able to kind of globally distribute that manufacturing technology and make it all by ourselves in the UK functionally, is because we leverage our own technologies inside of our manufacturing process. So just those technologies alone allow us to really scale the concept of manufacturing, not only on the chip cutting side, but also on the AM side as well. So that's really what does it for us, as far as I'm concerned.
Very cool. Yeah, that's awesome. And you've touched on it a little bit, but very rich history as an organization and manufacturing, specifically in metrology. Precision is of the utmost importance there. Just tell us, how you're able to kind of leverage that longstanding history and what that means for the organization today.
Yeah, certainly. So it kind of like has a slide deck here says we initially started off in the laser powder bed fusion technology as an end user of the product. Back in the 2010-ish era of Renishaw, we had a product line called the Medical Dental Division, where in the UK we manufactured dental products with cobalt chrome with laser powder bed fusion technology. So think like RPDs, removable partial dentures, crowns, caps, abutments, things of that nature, right? At that time, we identified throughout our manufacturing process that the machines themselves at that era of the technology stack were not up to par, if you will, to really blend in and fit into a traditional manufacturing process. The consequence of that, we didn't find them to really be as useful as they could have been. So the consequence, again, we decided to purchase the company that we were buying our machine products from, laser powder bed fusion technology. And ever since that juncture, about 2011, we've been slowly integrating our own technology suite and stack into our current flagship product, the Renem 500 series platform that Mike is leveraging down at Knust-Godwin. So everything that we've done from that has been a vertical integration approach to implementing new technologies into that platform, whether it's laser optical control systems, gas flow, CFD, dynamic control inside the weld process, or even a secondary or upfront software side of the process as well. This kind of depends upon what we're dealing with, right? But overall, we're continuing to upgrade that platform and continue to increase its production rate, i.e. capacity inside the manufacturing space, and make sure our customers are fully up to speed with what they need to do to be successful with their businesses.
Yeah. So that's interesting, the that you were a user of the technology and you were able to take some of those learnings. I imagine now you're relying on the customers for those kind of feedback, and having customers like, Mike, that have been able to be really successful with your technology, both validates what you're doing, but I think provides a really good feedback loop for innovation, that we see in the machine today. I mean, any examples of kind of some of those innovations and how they've allowed your customers to be successful?
Yeah, I mean, we're nowhere today without our customers, right? So from the OEM's perspective, we're not just here to sell a machine, right? We're here to make sure that our customers have confidence, awareness, and expertise in the platform. We like to think that the Renishaw system is open enough in the sense that it allows the customers to develop their own process, their own IP to their manufacturing space, which allows them to really hone in on what they need to do to be successful within their individual business. Things that Mike at Knust need to be able to do are significantly different than what another customer needs to do. So we have to try to make sure that that platform is amenable to all different types of laser powder diffusion manufacturing, if you will, i.e. medical device, all the way to oil and gas, for example. Right. But overall, things like, the name of the game, right, is when we go to put a machine platform into the facility it's a cost per part example, right? And we want to make sure that we're selling the machines into markets that are real parts, real applications, right? So anything we can do to increase reliability and increase the productivity of that machine, as it currently stands, are what we're really driving to in the market right now.
Right. Yeah. I know machine uptime is key here. It doesn't, if you build the part quickly, but you're down for weeks at a time between builds, then the minutes or hours you may have saved on the build, the equation crumbles pretty quickly.
It certainly does, yes. And we do a lot of work to support our customers from a training perspective to make sure they're up and running as best as possible in that regard. Because at some juncture, when you get to have so many machines, service engineers will help, right, keep everything running. But at the end of the day, they have to be able to control their own process, right? They need to be able to drive that themselves, and that's what we again try to drive for moving forward.
Yeah, and I'm sure it helps. You mentioned a few times openness that's key to customers feeling like they're okay to get hands-on with something, and that they don't have this black box that they're not able to control or make minor fixes to as they come across things, which in a manufacturing environment inevitably you're going to come across.
And correct, and that's going to go full circle back into the whole qualification step that Mike talked about prior, right? The standards organizations are doing a great job trying to develop these, process control documentations and identify the key variables that are critical from a statistical process control perspective. So again,
Right.
having the user have the functionality to be able to control those levers, if you will, is what Mike and his team needs to be successful.
Yeah. Yeah. No, outstanding organization, clearly a leader in this space, and one that we're really excited to be telling this story alongside. I think between yourself and Mike, we're just really honored to kind of share the stage with two companies that have established themselves as a quality leader in the space, and as an innovative leader in the space. And I'll take a little bit of time here to just give those people on the call who may not be familiar with Continuum Powders a little bit of an overview of some of the things that we offer. And similar to Knust and similar to Renishaw, for us, quality is in our bones, and it's where we, as an organization, want to hold ourselves to the highest standard. Is that we make high quality gas atomized powder, which, as Mike was able to demonstrate for us in some of his charts there, exceed a lot of the existing requirements and standards and specifications that our customers have. And that alone is a huge benefit for Continuum as a supplier to machine OEMs, to service bureaus, to end users who are making parts in the oil, gas, and aerospace industry, is that our powder is of the highest quality. Some of the other things that we hold ourselves to are this powder life cycle management, and our ability to take end-of-life components and put them back into service by atomizing them and creating spherical powder. I'll talk about that a little bit on the next slide here. for us, this process really starts at the reclamation phase, and it's what Continuum does all day, every day is we work with different dealers to procure end-of-life parts, high quality metal units, which feed into our atomization process. This case study that we spoke about today was a case where we were actually able to take end-of-life components from a customer, turn it into powder, and provide that back to the same customer. That's not the case for all of our business today. You know, a lot of what we do is just provide powder to people who are looking for high quality ASTM spec powder, and they know that it meets all of their standards and that it is also low carbon and good and green powder. Where we, you know, can continue to differentiate is in our ability to offset that reclamation with any waste that Mike has from a powder standpoint, or that John's end user customers have, whether it's in the oil and gas space, in the industrial gas turbine space, where someone may have high quality proprietary alloys that they want to melt down and use for using laser powder bed fusion or DED or binder jet. So, you know, for us, this is what we mean when we talk about creating a circular economy. Continuum has created a circular economy, and we are opening the door to all of our customers and to our partners to participate by helping us to offset that reclamation with expensive scrap streams that they may have today. Some of the powders that we use today, or a lot of the alloys that we specialize in today, are the nickel 718, nickel 625, stainlesses. We do work in titanium as well. So really going after those high production applications within the additive manufacturing space. And then, you know, I'll just kind of end on this slide here, where what I tell a lot of our customers and partners is that we're very similar to your current suppliers, where you want us to be similar, and we're differentiated in areas that you'd want to see us differentiated. I mean, we're at the end of the day, I've probably emphasized this too much, but it's just gas atomized powder. We get a homogeneous melt. The powder is ASTM certified, and it's high sphericity powder. Where we're differentiated is our commitment to using 100% recycled material, reclaimed powder waste, and our ability to recycle argon gas and run on a clean energy power grid. All of those things that help to make us the low carbon powder provider within the industry. Again, I'll just take it back to where Mike kind of started this conversation, talking about additive manufacturing, and where he was most successful was when he was able to find customers that were willing to invest in additive manufacturing, and they've leveraged additive manufacturing where there was a win-win, where it made economical sense, where they were able to reduce lead times. John said the same thing, emphasizing real customers, real parts. You know, our story is very similar. We are confident that while providing low carbon powder, we can also provide economical advantages to via material credits, and ensuring that we don't expect our customers to pay any more for low carbon powder than they pay for what they're getting today. Our customers are getting powder which meets or exceeds their current powder specifications, and is as economical or more economical than what they're paying today. So for us, we're really excited to be sharing this story about sustainability, about a circular powder economy. We're excited to be standing here alongside some industry veterans who have endorsed this product and this solution. And we look forward to working with some of the people on the call here today to answer their questions about powder and sustainability and recyclability, and how we can begin to partner and grow the Continuum footprint. So we'll kind of pause here and let the chat fill up with some questions. I'm sure there's a lot of people who would like to get some questions answered while we're here on the call today. So if you have those questions, please feel free to put them in the chat now. Brady will help us to kind of navigate the questions. And also, if there's a question that you don't feel comfortable asking now, please feel free to reach out to us via any of the contacts listed on the screen here. We've got Mike's Corliss's the sales phone, the sales email address on the screen here, as well as the Renishaw email address, and myself is listed, michael.brennan@continuumpowders.com. But again, any questions that you guys have, feel free to load them into the chat now. Mike, I've got quite a few questions here queued up in the chat, so I hope you're ready. Let me see here a good place to start for us. I got an easy one for you, asking about the different alloys that are available at Knust and what you guys printed in. I know you printed. You mentioned some exotic alloys, or you guys specialize in the hard to do, hard to get done. So I guess this maybe is an easy one. Kind of just what kind of alloys do you guys generally use at Knust?
We print a lot in Inconel 718. We have 5 systems in Inconel 718 today. Titanium, GR cop, cobalt-based materials, and 17-4. Those are our high runner, our production machines. We also print other alloys, aluminum, some Inconel 625, and some M300 tool steel in some of our single laser machines. But yeah, that's the range right now today.
Yep. Okay, I got a question here from the other side of our friends to the north in Canada. Where are Continuum's processing facilities? Would you consider installing more in other regions? Yeah, great question. So Continuum is located today. We have a couple locations across the globe. We have a location in Singapore to support our Asia Pacific market. We have a location in Cloverdale, California, where we build our atomizers and where we operate a couple of our atomizers today. And then our flagship facility is going right in Mike's backyard in Houston, Texas. And that will be online later this year. And that's in Houston proper. So a pretty good distribution of assets, I think, across the United States as well as globally. And then the second part of that question is, would you consider installing more in other regions? And I think the answer is definitely yes. It's something we didn't spend a lot of time talking about on this webinar, though, is the compact nature of our atomizer and its ability to be local in some cases, where demands would justify something like that. So that's certainly something that we've had discussions with our more strategic customers about. So great question from our neighbors to the north. Let me see what else we've got here. How does the recycling process affect the chemical composition? Can it be applied to reactive materials like titanium? To start with the second part of that question, yes, we atomize titanium today, and we offer grade 5 titanium. How does the recycling process affect the chemical composition? The answer there is that our process doesn't have an impact on the chemical composition. Our process is uses a plasma torch to melt down the material in a cold hearth, and basically the alloys that we put in are the alloys that we get out. We have quality control QMS systems in place where we collect our scrap, or where we collect our end-of-life components, where parts are cleaned and are tested for chemical composition. We test material as it comes into our facility. We test material as it's atomized, our homogeneous melt, and then finally we test the powder that comes out of the atomizer. So we really have quite a few touch points and able to where we're able to determine the chemistry of what we're melting, and it's not something that we ever take for granted. It's something that we test throughout the process, and it's very important to us that we catch if there's anything in there that shouldn't be, that we catch it as early as possible.
Hey, Michael, we also have Sunil on. I upgraded him to a panelist. So Sunil, if you have any questions you want to answer, feel free to chime in.
Sure. Yeah, on this question, Yevgeny, yes, as Michael said, what chemistry for the main chemistry of the alloy, what chemistry goes in, that comes out. So we really don't affect any chemistry. We don't have any material loss, or we don't add any materials. But as far as the reactive metals is concerned, yes, we have ability and we have a technology to reduce oxygen in the material as we are atomizing. So it's a one-step process, atomizing and oxygen reduction. So we can handle reactive metals, yes.
Yeah, thanks, Sunil. That's great. I got one for Greg here. I think it's a very good question. The comment or question here is that atomization is a very efficient process in terms of energy usage already, which is partially true. What are the improvements that Continuum has made to an already efficient process? What do we do differently? I think when you think about carbon footprint, it's not only just the process, but also the feedstock. And I think Continuum has taken a crack at reducing our carbon footprint in both of those areas. So, Greg, maybe you can break it down and talk about it in that way.
Yeah, I think, thanks, Michael. One of the very unique aspects is you called it melt to powder earlier, I think, as you described the gas atomization system that we use. It tends to be very efficient, where again you're taking a known alloy material into the crucible or the cold hearth and melting it in one step, generating the stream of metal and atomizing it to powder. So that energy input is what I like to think of as just sort of it's one time. It's the melt and it's the powder atomization. I've often said that we're not the ones who invented recycling metal units. That's been going on for as long as we've been turning swords into plowshares. There's been a desire to maintain the value of a metal unit. But I think what's unique here is that once you know what the alloy is, if you're able to put it into a melt pool and atomize it, you can have a very high degree of confidence that the alloy that's coming out is what you expect it to be. But as far as energy efficiency, alternatively, you would take that back to a VIM furnace and maybe start with a new ingot and alloy it up and forge it and maybe make a bar out of it, maybe make wire out of it. All those steps add a lot of heat, a lot of energy, a lot of work, and all of those steps are effectively mitigated by just going melt to powder. So I think we can show, I think there's another question here about LCA, and have we done that? It's very easy to show that the significant reduction of total energy input to go from an already alloyed material directly to powder.
Yeah, I think that's a great point on the feedstock, Greg. And then additionally, maybe just talk about some of the other things that are in place from green energy or our recycling process that are in place to take an already efficient process and make it more efficient.
Yeah. And beyond that, I don't know if Michael mentioned our facilities in Houston, Texas. One of the reasons that we're locating there is certainly the availability of material without a lot of transportation energy required to get it to our gas atomizing foundries. But it's also a very friendly energy grid with respect to getting some green energy sources that we can operate our plasma torch with. And we're also gone to take the step of securing the industrial gases that we consume from the lowest possible energy input as we can, because again, the gas inputs are not insignificant, and since we want to do the best we can everywhere we touch the material, we go out of our way to make sure we source that as responsibly as we can.
With all of these green steps, Greg, surely the cost is more expensive, right? I mean, how can you how could one possibly provide market pricing with all of these green initiatives that you're describing?
You're nice softball, Michael. Look, there was another question here about are the products priced at market, and the answer that I often say is it has to be priced at market. No, as nice of a story as it is to be doing the right sustainable things for the environment. We are all in a very competitive business. You know, I don't need, you know, Mike will be the first. Mike Corliss will be the first to tell you he has to compete first. So his quality has to be the same. His cost can't be any higher. Nobody's gonna pay him 15% more because he's offering sustainability. And so we know that. And frankly, we've demonstrated we can compete at market, and we have to. Again, we believe we have to. But we also believe that once we deliver that benefit of also doing those things at the same quality, at the same performance in the machine, the throughput in Mike's machine, the mechanical properties, and the price, you have to be pretty cold-hearted to not say, well, I'm saving the planet along the way. I'm not really that interested. I mean, that's the hook we like to set. And once Mike's growing his business and John's selling more printers because we're offering a unique solution at a competitive value, that's where we're pretty excited about what we're offering here and telling the story.
Yeah, definitely. I think, you know, Mike talked about it a little bit at the beginning that it has to make sense, and it has to work. And I think that's a big thing that we're trying to drive home here is that, you know, we want to be saving our customers, from a sustainability standpoint, but also just economically. And I think you did a good job answering that. So let me check the chat here and see if we've got any other softballs or if it's time to dive into the harder questions here. To measure, see if there's any. This is a great one. Do you think it would be feasible to use end-of-life components with coatings for powder atomization?
You want
Sounds
to tackle
awfully
that one,
familiar.
Michael?
Yeah.
Sounds like a
So,
Sunil one.
You know,
Yes, I think it's possible, but there is a pre-processing step involved, which includes the removal of coating. And as we explained before, that what goes in by chemistry, that comes out. So we have to make sure that the chemistry, what is going in, is the basic alloy chemistry and nothing else. So yes, to answer your question, yes, it is possible with a pre-processing step involved.
I would say it's possible and it's being done.
Yes, it is being done as we speak now. Yeah.
thanks, Sunil, for taking that one. Right. Well, we're kind of coming to the end here of the questions that we've got, and I think there's been some good dialogue today. Any kind of just parting comments as we go to wrap things up from yourself, Mike or Greg? Anything that you felt like maybe we left unanswered, want to put a little bit more color on? We're kind of coming to the end of our 50 minutes here. Appreciate everybody joining us today. A really strong turnout, great engagement on the questions, and very happy to be telling this story. But just as we close, Mike, anything just to put a bow on it for us?
Yeah, everybody talks about the quality of the material. We purchase to a very high standard, and the chemistry has to be held really tight and close. And we do not see any degradation in the chemistry of the powder that we have received and have been using in the past from Continuum. So it speaks highly of their process and what's going on here, and metal in, powder out. It's very good quality stuff, and we're excited about it. I mean, we're growing with this application and opportunity, and so we're excited about it. Like I mentioned early on, it's not a one-time off or anything like that. We have dedicated resources in producing products with this material. So we look forward to the continuous growth and even other alloys as well in the future. Yeah.
Thanks, Mike. Anything from you, Greg?
No, I think one of the questions that I anticipated was, hey, I don't have that much scrap, or I don't have enough metal to supply you to feed my needs. I think you mentioned a little bit, Michael, as you were describing that circular slide, or that circularity image or graphic. a couple of things I think it's important. When people hear that we recycle powder, or we're in the business of recycling metals into powders. We're not magicians, we can't take mixed powders in barrels filled with garbage and expect to, melt them again and return you something that's magically wonderful. That's not our claim. But if we, as everybody said here, if we know what the chemistry is going in, then there's a really high degree of confidence that when we go to do the COA at the end of the cycle, it's going to be in spec. If it's not, we've wasted a lot of money and time to produce that powder, and it'll never make it out the back door. So I just like to, let people know that, you don't have to be generating enough waste for us to be your supplier. We'll go get it. We understand how absolutely critical, mixing of materials is not okay. Contaminants in the material is not okay. We have to be confident that plasma torch is burning off any residue or soap or anything that may come in on a metal unit that's been cleaned. It has to be gone. It has to, meet chemistry at the end of the day. Or let's face it, we wouldn't be delivering Mike Corliss the quality he needs if we didn't take those things seriously, and we do. And we want to do it for the rest of y'all on the phone. So
amazing. Thanks for helping us, guys. Thanks for jumping in for the Q&A, Greg and Sunil. One last time, thank you to everybody on the call. We look forward to kind of communicating with each of you after this call, answering any additional questions you have, and finding a way to kind of grow our partnerships and our network. So, please keep an eye out for correspondence from us. We're really eager to engage with everybody here. So thanks, everybody.